Okay, let's have a look at how we convert between units of pressure. So if we've got 1 atmosphere, we know that that's equal to 101,325 pascals. But let's say we were given a question that required us to convert 2.2 atmospheres to pascals. How would we go about doing it? Well, there's a simple mechanism that we can do this conversion. If we know the correct conversion between the two, we can actually cross-multiply between what we know and what we don't know. So we get 1 atmosphere times our unknown in pascals, and we cross-multiply that part. And we cross-multiply that to equal what we do know in this case, which is 2.2 atmospheres times 101,325. This sets up a ratio of 2 equal parts. So this part will equal this part. And from there, it's a simple question of rearranging our formula to give us our unknown. So in this case, we've got 101,325 times our 2.2, because that part is cross-multiplied, divided by our 1 from this part here. So in this case, we get an answer of 202,915 pascals. Whenever we do a calculation, we should always ask, does it make sense? Well, we're going from 1 atmosphere to just over 2 atmospheres. So if we look at our answer, we're going from 101,000, close to 101,000, to 220,000 or thereabouts. So yes, our answer does make sense. Let's look at one slightly more complex. So we've got 760 millimetres of mercury being equal or equivalent to 14.7 psi, units that are not as commonly used these days. But let's do a conversion in this case. We're told in our question that we've got 6 psi. So if we think about it, we've gone just under half our pressure. So that means that our pressure, when we convert psi to millimetres of mercury, should be just under half the value of 760. So once again, for us to do this conversion, we cross-multiply. So we get 6 times 760 is equal to our unknown millimetres of mercury times 14.7 psi. So we can make these two equivalent. So 760 times 6 from this part is equal to 14.7 times our unknown. And if we isolate for our unknown, we get 760 times 6 divided by the 14.7. And if we do that calculation, we get 310 millimetres of mercury. So we ask the question again, does it make sense? Well, we've gone down by half, or a little over half. We've gone from 760 to 310, so yes, our number does make sense. So let's have a look at a temperature conversion between degrees centigrade and degrees Kelvin. Now our relationship is that at 0 degrees Kelvin, our degrees centigrade is minus 273.15. Or we could write that another way. 0 degrees Celsius is equal to plus 273.15 degrees Kelvin. So in a question we're asked for the conversion of 25 degrees Celsius to degrees Kelvin. So in this case we've got to add 273.15 to our degrees Celsius measurement. So in this case we've got 25 being our new measurement plus the 273 will give us 298.15 Kelvin. Fairly straightforward. What about we get a conversion between Kelvin to degrees Celsius? Well, in this case we have to subtract our 273. So we start with 100, so 100 minus 273 will give us minus 173.15. Once again, we always ask the question, do these numbers make sense? Let's have a look at this first one. We're at 25 degrees, so we've got to be higher than the 273. So our 298 does make sense. We're higher than that 273. What about the second one? 100 degrees Kelvin is less than the 273 degrees Kelvin, which means that our degrees Celsius should be less than 0. So in this case, we've got minus 173, so yes, that does make sense as well.